Hey everybody, this is your calculus review video on 5.3 to 5.4. Now before I actually get into that, I want to go over 33 from 5.4 and also have a little hint right here which I'm going to get into first. So to start with, on trig functions you got to be careful. If you're taking the derivative of sine, it's cosine. And so if you do the integral of cosine, it's sine. So both of those are positive. And you could have both negative. So in other words, it's the same sign. But on this side, if you're doing the derivative of cosine, it's negative sine. And so if you need to do the integral of negative sine, it's positive cosine. So also thinking about it this way, if you're doing the derivative of negative cosine, it's sine. And if you're doing the integral of sine, it's negative cosine. So in other words, on these, you have to change your sign from positive to negative. So just keep that in mind as what you're doing. If you're doing the derivative of cosine, it's negative. And if you're doing the integral of sine, it's negative. Because I have seen them both ways. So on this one, which was 33, we're doing cosine 15t. And it goes through all the steps. But basically, the most important thing is you're doing your integral first. So if you're doing an integral of cosine, it's going to be sine, and it's positive, and you're going to need your 15t on top and your 15 here. And then when we do the chain rule on it, you end up getting cosine 15 square root of x over 2 square root of x. So the problem originally had to do with cosine. You see, you get to the right page. The problem originally had to do with cosine. It's cosine 15t, and our answer was cosine 15 square root of x over 2 square root of x. And then for the bottom part, for the part B, you get the exact same answer. So on 33, you will have something different, and then the bottom two ones will be the same. So I went through a few examples of this. On this one, we started with sine of 5t dt. When we do our integral first, we're going to get negative cosine 5 squared of x over 5. So this number goes on top and bottom like that. And since we were doing the integral of sine, like I said over here, the integral of sine is negative cosine. And so that's why this was negative cosine 5 squared of 5 over 5. And then for the other part, you get sine 5 squared of x over 2 squared of x. So again, that number on top and then the 2 squared of x on bottom. So you can use these as examples in your notes. And then on this one, again, similar to the cosine 15, if we do cosine of 8, then we get positive sine 8 squared of x over 8. And then cosine 8 squared of x over 2 squared of x for the other two answers. So hope that part helps. And then also we'll get into more, including the area question. Okay, so on the area question, which is number 47, first I'm going to graph it and then use this interval. So there's my graph and then the interval. So I'm setting my window and changing it from -7 to 5 for x. Okay, there's my graph. And we need to break it up into subintervals on which it does not change sign. So looks like they use 0 and 3 from here, because if you factor out a x, actually factor out a negative x, you'd have x plus 3 equals 0, which eventually would get you to this. So they did use the 0 to negative 3. So what they noticed is on negative 7 to negative 3, it's down, so the sign is negative. And on negative 3 to 0, it's positive. And then from 0 to 5, it'd be negative. So another way, just real quick, if you do your 0 of the graph between here and here, that's negative 3, 0, which is what they used. So the most important thing about this is do your 3 separate steps. And in this particular one, it was minus, then plus, then minus, based on where it was. Now, here they just did the integrals, sorry, and these are based on doing the antiderivative of this. So remember, if you have x squared, you bump it up to x cubed and then do 1/3 of that. So this is negative x cubed over 3. And on this one, you bump this up a power to 2, make it a half in front. So negative 3/2 x squared. So these are the answers they got from doing the integrals. And then the total area is the sum. And the most important thing that some people didn't catch or whatever, or I didn't catch the first time, is you need to do the absolute value of each one. So if you do that, then you should get the right answer. Okay, so now for the actual review. On this one, what they want you to do is just rewrite this in a different form. And so you see your interval here. You're going to put 3 on bottom and 6 on top. So the reason for that is the lower is always on bottom on this, and your upper is on top. So then the next part is you just look at this part and you put 1 over 2 minus 3, and you change ck to be x, and then you need dx. So that's that one. Okay, so there's the first. On the next one, we have a few functions, and on the first one, notice if you're going from, same number for the top and bottom, that answer is going to be 0. Now on this one, we're going from 7 to 2, so this is actually written wrong. You have to adjust it to be normal. And so the normal way would be put 2 here and put 7 here. And if you're going to do that, then you have to change the sign. And we're using g of x. And so then g of x is up here, and it was negative 5. So I need a minus a negative 5, which is 5. So 5 would be my answer. Now on this one, they want 3 times g, and g was negative 5, so we just do 3 times negative 5, which is negative 15. On this one, we want 4 to 7. Now, when you look up here, there is no 4 to 7. There's 2 to 4 and 2 to 7. And so we're going to have to break that up. So what we do is we take the 2 to 7 of f of x, which is more than you want, because what you want is 4, minus the little part from 2 to 4 of f of x dx. And so then you just plug in your numbers. And so the 2 to 7 was negative 3, minus the 2 to 4 was negative 5. So that'd be really negative 3 plus 5. And so you get 2. So negative 3 minus a negative 5, so negative 3 plus 5 is 2. Now this one we want to use 2 to 7 for both G and F. So the 2 to 7 for G was given to be negative 5 minus the 2 to 7 for F is negative 3. So here I get negative 5 plus 3, so that's negative 2. And then on this one, again, we're going 2 to 7, and we need 6 times the G answer, which was negative 5, minus the F answer, which was negative 3. So here we get negative 30 plus 3 is negative 27. Okay. On your next one, graph the integrand and use the known area formulas. So first they want you to graph it over here, and we're just doing 5 minus the absolute value of x. So without a calculator, you know 5 would be the y-intercept, and your slope is 1, so that would look like this. Then just continue it. This would go through 5 here and through negative 5 here. Whoops, I missed. Oh well. You see that should be 5. So it's just based on that number. Now on the integral, we just need to do it from negative 1 to 1. So this is one where you should probably use your calculator to be easy. 5 minus, use the button to the right of the 9, and over here is the absolute value, x. So what we're going to do is the integral, so we do menu, analyze, integral is number 6. On your lower bound, put negative 1, enter. And on your upper, push 1, enter. And then it tells me the answer right there, it's 9. So that's from the calculator. So that was analyze graph, and then integral. And then my lower was negative 1, my upper was 1. Okay. On this one, you want to use your 0 to the cube root of 14. So let's try using the calculator for this one. By the way, if I ever say type your function is the x squared part, it's not the integral. So type your function. X squared, enter, and then we want to analyze integral 0, and then the upper bound we need control up arrow put a 3 here, and, well, it's the cube root of 14. Let's see if this is working right. Okay, so this one isn't working correct in the calculator. I could probably figure out how real quick. So if we go to nth root and put 3, 14, I need this as a decimal. Copy. Analyze integral. Our lower was 0, and our upper I want to paste. Okay, it didn't like how I did it. Okay, I was hoping it would do it right, but it didn't. Okay, so this is one we'll do by hand. Didn't like that. So what you do is basically plug in the cube root of 14. So you have the cube root of 14 cubed over 3, because that's your b, minus 0 cubed over 3, and then type that out. Well, that would just be 14 thirds. Yeah, that's all that is. Because if you do the cubing of something cube root, it goes away, so it's just 14 thirds minus 0. So that one you didn't have to use the calculator. But if you do like to double check, the cube root of 14 is about 2.41014. I'm just being persistent on this other one. I want to clear that out. And put x squared. Oops, not g. And then analyze the integral from 0 to 2.41014. Okay, so this gives me 4.6 repeat, basically. I mean, you do have to realize these other numbers are not accurate because I only put a few decimal places here. But if you just use your mind and put a bunch of 6s here halfway to the screen and then approximate that to a fraction, and it worked. Okay, so you had to use a decimal in order to use the calculator. So there you go. Then we converted that to a fraction, which is 14 thirds. Okay, I hope I'm going slow enough on the review. I'm purposely not trying to go too fast so y'all would get it, pretty easily. Okay, on the next one we're doing with variables, so you can't use your calculator on this one. The high end was 9a, and so if we just plug that in here, 9a squared over 2 minus a squared over 2. So that's 81a squared over 2 minus a squared over 2. Well, doesn't that just give you 80a squared over 2 from like terms? And then both numbers are even, so you can divide it and get 40a squared. 40a squared. So you already had a common denominator, so you can do that. Okay, on your next one, we're showing from 7 to 3 of 7. And the first step would be reverse it and go from 3 to 7 of 7. So remember, whenever you reverse it, you have to change the sign. So this is 7dx. Now this particular formula is up here. It shows you what you use. It's c times b minus a. So this would be negative 7 times 7 minus 3. So that's negative 7 times 4, which is negative 28. Okay, and then on this one we're getting an area, and it's going from 0 to b, and you're using 6x. Okay, so if you're using 6, then you're going to do, basically think of it as the integral of 6x. And what we do is we put the 6 in front, and then we're going to go from 0 to b like this, and then put x dx. Okay, I'm not completely done with that yet. That was just my first step. The next step is to actually do the integral of that. So I have my 6, which is in front, and I change this to be like brackets, and the integral of x would be bumping it up a power and put a half here, then minus 0, and we're evaluating this from 0 to b, so this would be 3b squared minus 0, so just 3b squared. So like I said before, the derivatives and integrals are like opposites. They're kind of like inverses. So like, remember, the derivative of 6x would be 6, but the integral of 6x would be, you put that and then that. Okay, so now for the 5-4 questions. This one you want to go from 0 to 3 of 5x times x minus 3. So let's try this on the calculator. Add graph 5x times, so make sure you put that little times symbol, and we're going to have x minus 3 here, and then just analyze integral 0, enter 3, enter. That gives you negative 22.5. Now on my paper review, it has it as a fraction. So what you would do is type negative 22.5, menu number, fraction, and it gives you negative 45 halves. It does just say simplify your answer, so it may take that, but on mine it took the fraction. Okay, on this next one, we have 3x squared minus x to the third power over 4. Okay, so there it is. And you want the integral from 1 to 2. Menu, analyze, integral, 1, enter, 2, enter. Okay, so I get 6.0625. So go over here, 6.0625 as a fraction is 97/16. So again, this is the easiest way to do it, and that was the correct answer. Okay, so now to the trig one. This one, if you remember, we had the derivative of tangent is secant squared. And so this one's going to need an exact answer. So unless you recognize whatever decimal we have and then change it to a square root, you're going to have to do this one on paper. So my first step on this would be put the 3 in front, and let's put the 3 in front. You're going from 0 to pi 6. And since I said the derivative of tangent is secant squared, that means the integral of secant squared is tangent. Because it's kind of like that circle thing I did earlier. If you have tangent and you're doing the derivative, then you get secant squared. But then if you do the integral, it'd be tangent. The integral of secant squared is tangent. So this is the direction we're going, like that. Okay, so we put 3 tan x, and then this is where you're probably going to need your unit circle. You're going to do 3 times tan pi 6 minus tan 0. Okay, so unit circle, at 0 we have 1 comma 0, which means your tangent would be the y over x, so that's just 0. And then for pi 6, pi 6 is like 30 degrees, and so it's square root of 3 over 2 1/2, and so this would be 1 over square root of 3. So here we have 3 and then 1 over square root of 3 minus 0. So this is just 3 over square root of 3, which is just square root of 3. If you get confused by that, just think of it as because the numerator could have been square root of 3 times square root of 3, and the denominator is square root of 3, so it cancels. So your answer is square root of 3. Okay, so let's check this same thing on the calculator. You want to do add graph. Now, by the way, I also caught a calculator flaw, while I was doing this. You do 3 and then open parentheses, secant x squared. Okay, there's your graph. And you want to do menu, analyze, the integral. Well, what I noticed is when you do the integral, at first it says lower bound, you put your 0, but if it's doing the upper integral now, well, now it's showing up. It says upper bound, so never mind. The upper bound, I'm going to put pi over 6. I know one time it gave me lower for both, which didn't make sense. Okay, so what I recognize is if I do this on the calculator, I get 1.732, so forth. And so remember, if we go square root of 3, control enter, there's your 1.732. So that's how you can tell you have the right answer. Okay, on this one we're finding the derivative first. So what we do is we rewrite this as u to the 7/2 because the denominator is the root. And we need the integral of u to the 7/2. So we would bump it up a power. So you think 2/2 plus 7/2 is 9/2. Then you put a 2/9 in front. Now we have to evaluate that from 0 to t8ths. So what I have is 2/9 t8ths to the 9/2 power minus 0. Okay, well this is a power to a power, multiply the power, and so I get 2/9 t to the 36. So you could think of it as 72 divided by 2 or 4 times 9. Depending on how you want to do your math on the exponents. So it's a power to a power, multiply the power, and so that's your answer. So 2/9 t to the 36. Now you may see it as 2t36 over 9, which is fine also. Okay, now what we need to do is the derivative of that. So if we start with 2/9 t to the 36 and we want the derivative, then you keep your 2/9, you bring down the 36 and lower this a power. So then you would get 8t to the 35th. And that's when I said, you know, both of those answers are going to end up being the same. And then on this multiple choice one, what you're doing is you're substituting t for u and then multiplying by the derivative of t to the 8th. Okay, and then on this one, we just change this. Instead of t, you use x. So square root of 13 plus 14x squared. Okay. And then on this one, you're doing the integral from 0 to cosine of dt over the square root of 1 minus t squared going from 0 to pi. So that means you shouldn't get a negative answer here. Hold on, let me think through this. Okay, let's just work it out. Your original interval is this, but that doesn't mean your answer has to be in that interval. Okay, so just working through this, we're going to do our integral of this. So first we're going to call it 1 over the square root 1 minus cosine squared x and then you need the derivative with respect to x of cosine x. So on that first page we said the derivative of cosine is negative sine, and on this part, remember you have sine squared x plus cosine squared x equal 1. So sine squared x is 1 minus cosine squared x. And so then this part is going to be the square root of sine squared x, which is sine x. So we have 1 over sine x. Now, since we have 1 over sine x times negative sine x, this answer is going to be negative 1. Okay? And then, just to be completely honest, I accidentally chose 46 instead of 47, which was the area problem, but it's just like this one. So this was one that's similar to 45, but you didn't do. So let's just work through this. So you're basically going from cosine to 0. So this one would be 1 over the square root what I just realized on my review copy is everything's the same, like even the integral, except for this is flipped, and so it's going to be negative of my answer. So it's going to be 1. So here, let me do the work. 1 over square root 1 minus 0 squared well, that's the square root of 1 over 1, which is 1. Then minus 1 over the square root 1 minus cosine squared x. And so this one, and then we would need the derivative also. Let's see, the derivative with respect to x of cosine x. By the way, I think over here I forgot to do the derivative with respect to x of 1. And the derivative of any number is 0, so this 0 is going to go away. And we have a minus sign, and this we know is 1 over sine x. And the derivative of cosine is negative sine x. So the negatives cancel, and so you get sine x over sine x, which is 1. So that does work out to be right. It's 1. Okay, I hope that helps.